Hello everyone, I'm Jingyi Yuan and our group number is XiangbingJi and Xinzhe Yu. Our topic is New York City Taxi Data Analysis. First, we will do a presentation of this project. Second is the demo of our website. And finally, we will briefly introduce our code. This project aims to build a web application telling the drivers real-time demands of taxi in New York City. We have four main functionalities. The first one is to show the importance of each factor that influence the taxi demands. Second is plot density map to show the demands of taxi. And third one is to show clusters for high taxi demand on Google Map and predict taxi pickup demands based on a specific time and location. The fourth one is visualize our New York City taxi dataset. Here are tools and algorithms we used. We use data from New York City taxi trip record data and choose records of green taxi from January 2016 to June 2016. We use Hadoop and Pick to clean the data by only choosing pickup and drop-off dates and times, pickup and drop-off locations, and total amounts as features. Meanwhile, we split our dataset into 24 subsets in order to do real-time analysis. For backend, we use random forest to get feature importance. At each tree split, the improvements in the split criteria is the importance given to the splitting feature, and here is the result of importance of each feature. As we can see, the latitude and longitude, together the location, has most significant influence on the number of pickup.
This is our density map of our dataset, which corresponds to the real-time real pickup data. And we can see that there are several clusters, and we can see that the number of the pickups at 5 p.m. is more than that at 1 a.m. We will compare the density map with our Gaussian mixture model later. This is our Gaussian mixture model. We can see that there are several clusters in map, and the size of each cluster represents the size of the cluster. Compared with our density map, we can see that the Gaussian mixture model is reliable and fits the density map well. Now I'll show you our prediction results. Firstly, we choose a time and location, and we get the real pickup number. Then we make a prediction on our website. We can see that the real pickup number is 1829 and prediction result is 2002, so our prediction is reliable. Okay, the next part is website demo.
Cool. So I will show you guys our front end. So this is our front end. So so all the data are hard coded in our front end. So the user are able to use our website to do some pickup predictions and also to see some visualizations of the overall statistics. So this is the overall layout of our website, and it has three different sections: introduction, pickup, predictions, and these visualization. So when click on the navigation bar, you are able to navigate between this among those three different sections. And introduction is very simple; it's just some basic information about our project. And here then is the pickup predictions. So you can see that we use a Google map here, and you can choose a time. For example, I will choose time zone 3 to 4 a.m. and by click on the Google map, so our website can automatically get your latitude and longitude. So and then you can click submit. So it will show the predicted pickups in the vicinity. So it's about several blocks inside. So cool. So right now we can change the time zone, and we let the location stay the same. So for example, we can change to 8 a.m. to 9 a.m. and we submit again. Of course, we see that right now the pickup is over 2400, but before that you can see in the time zone 3 to 4 a.m. the pickups is only 60. So it also meets our daily life. Of course, you will have significantly more pickups during 8 to 9 a.m. then during 3 to 4 a.m. And you can also change the location. For example, let's change our time zone to 17 to 18 p.m. and we change the location. Right now we are in Manhattan, right? So since this is a green car, so there is no car in the midtown and downtown, but we can change our location to the, for example, here, Jackson Heights. It's in Queens, right? So we say predict again. We can compare the result with our result in Manhattan. Of course, we can see that all the number of pickups here is less than the number of pickups in Manhattan, and we can change another locations here. Okay, it's only 18. Definitely, this area is very far away from the city center, so of course, very few pickups here. But if we change to somewhere in Brooklyn, pickups go up again. So this actually shows our model is quite predictable actually according to our common sense, right? So and finally, I will show you the D3 visualization. So this section gives you overall statistical visualization of the whole New York City taxi pickup data. So this histogram shows the overall pickups with time and location, and then the pie chart here shows the proportion of each region in the total pickups. For example, the Brooklyn is about 35%, Manhattan is about 38%, and Queens is a little bit less. It's just 27%. And you can click on this chart or hover on this chart to see the number of pickups on a specific region changing with time. So it's quite interactive, and you can also hover on just one time zone, and you can see the proportion change of the 3 different regions as I hover on different time zone. So it's quite informative. For example, for the Manhattan, you can find after 9 a.m. so the number of pickups significantly drops. So it indicates a lot of information for the taxi driver. So yeah, so that's the overall demo of our front end. So I hope this can be helpful to you. And finally, this is the code organization. So this is our repo of our code. So we put all the front end code in this folder called front end. And you click on that, you can run your local host on that, and you click on the index.html. This is our homepage. And also for the source is all our data in the backend. All our algorithms are implemented here. So it consists of Gaussian mixture model code, prediction validation code, random forest code, and also some data reorganization code. Because the raw data is not usable, we have to reclean the data before doing the calculation. So finally, there are some results for our data. This is data, JSON data for the Gaussian mixture model, and also this is the data for the statistics feeding our D3 JavaScript. So, and for more information, you can just see the README file, and you will see detailed instructions about how to use our code. So cool. So that's the overall presentation of our final project. Thank you so much, and happy holidays.